Hello everybody, welcome to exercise 2. In this exercise, we will learn some Python data types. First, let's see number data types in Python. I'm going to introduce integer, float, and complex. Python supports integers, floating point numbers, and complex numbers. Integers and floating points are separated by the presence or absence of a decimal point. Complex numbers are written in the form x plus yj, where x is the real part and y is the imaginary part. Here, let's set a to 5 and print out its type. We can see that the type of a is integer. Let's set a to 5.0 and check its type. Now, a is float, because 5.0 contains a decimal point. Let's set a to complex number 5 plus 6j, and let's add 6 to it. To perform addition on complex numbers, just add the corresponding real and imaginary parts. Here, the real part is 6, and we have no imaginary part. So the result should be 5 plus 6 equals 11, 11 plus 6j. Next, let's see string. In Python, a string is a sequence of Unicode characters. Unicode was introduced to include every character in all languages. So a Python string can store text in different languages. Here, I can write Hello Python in Greek. And let's review how we can hold strings in Python. We can use double quotes, single quotes, and if a string contains multiple lines, use triple quotes. And here we can see the type of S1, S2, and S3 are string. Python also supports escape sequence. To insert characters that are illegal in a string, use an escape character. An escape character is a backslash followed by the character you want to insert. An escape sequence starts with a backslash and is interpreted differently. If we use a single quote to represent a string, all the single quotes inside the string must be escaped. For example, over here we have a string including double quote. If we don't write the escape character, the string ends here. And S will be a string followed by double quote, which is not a legal syntax. To treat the double quote as part of the string, we need to add an escape character before it. Same as backslash. If we want to treat a backslash as part of a string instead of an escape character, just put another backslash before it. The character behind a backslash will be treated differently. For example, \n means start a new line. Sometimes we may wish to ignore the escape sequence inside a string. To do this, we can replace lower r or upper R in front of the string. This will imply that it is a raw string and any escape sequence inside it will be ignored. For example, we're writing a file path on Windows. There will be a lot of backslashes. We can add R in front of the string to treat the escape characters as normal backslashes. We can also access characters in a string. To access characters in a string, we use indexing. Index starts from 0. Index 0 will be the first character of S. The first character of S is P. And here we can see the second character in Python in S is Y. In Python, we can also use negative index. Negative index starts from the end and goes backwards. Index -1 is the last character of S. The last character of S is N. Trying to access character out of index range will raise an index error. Also, index must be an integer. If we use float, there will be an error. To access a range of characters, use slicing. Here, 0 means start from index 0, which is P. And 3 means end before index 3, which is H. So end before H would be T. So the result is PYT. We can also specify the increment between each index for slicing. Here, 0 to 4 is PYTH. And 2 means the increment between each chosen index should be 2. We will have index 0. We won't have index 1 because the increment from index 0 to index 1 is 1. We will have index 2, and we won't have index 3. So the result is PT. Finally, we cannot change the value of a character inside a string. Next, I will introduce some string operations. There are many operations that can be performed with strings, which makes it one of the most used data types in Python. Here, I will demonstrate two Python string operations. First, the plus operator. We can use the plus operator to join two or more strings into a single one. Next, the multiply operator. We can use the multiply operator to repeat the string for a given number of times. Here I repeat hello 2 times. Next, let's see some common Python string methods. There are numerous methods available with the string object. First, let's take a look at how split works. With split, we can split a string with a delimiter. Here we have a string, Python is cool. I can split the string with a space as delimiter. We can also replace some substring in a string. For example, I can replace py in Python by abc. We can also convert a string to uppercase or lowercase. To lower a string, use string, here is s dot lower. To upper a string, use s dot upper. Lower, upper. Finally, we can join a string by a sequence. Here we have 3 strings. Python is cool. We can join them with this string. Python also supports string formatting. We can add placeholders inside a string and replace those placeholder with specified values. For example, %s is a placeholder for string, and %d is a placeholder for decimal. We then put the specified value inside the parenthesis after a percentage symbol. So s would be AI, and %d will be replaced by 63. Now let's move on to lists. Lists are mutable sequences typically used to store collections of homogeneous items. Here we create a list of integers. Usually, lists are used to store items of similar data types. It is possible to store different types of items in a list. For example, we can store digits together with a string. It won't cause an error, but in most cases, we only store items of similar data type in a list. Same as string, we can also access items in a list by indexing and slicing. Unlike strings, items in lists can be changed. Here, I changed the second item to 0. And lists operators are same as string operators. Here we can multiply list by 2, and we can add two lists together. Next, let's see some lists methods. To add an item to the end of a list, use append. Here I add fish to the end of this list. To delete an item from a list, use remove. Now let's remove fish. To insert an item at the defined index, use insert. Let's insert fish at index 1, so it should be between cat and dog. Now let's see the pop method. The pop method removes and returns the last item in a list. So bird will be removed and returned. And the enumerate method adds a counter to a list or any other sequences and returns it. This is the counter. The sort method returns the sorted list. Here we have list 1 sorted. And the reverse method reverses the list. In Python, we can create a list based on another list using list comprehension. The syntax of list comprehension usually involves control flow statement, which we will learn later. For now, you just need to know we can create a list based on another list, like this. This X means items in animals, and we perform multiply operation on X to create our new list squares. Finally, let's take a closer look at list indexing and slicing. List indexing returns the index of the specified element in the list. Here we have a list of two lists. The first index is the index of the outer list. So index 1 is this. And the second index is the index of the inner list. So index 0 will be 4. And list slicing is just the same as string slicing because they are both sequences. Next, let's see tuples. Tuples are immutable sequences. Its items cannot be changed after creation. Let's create a tuple including 3 items: a digit, a list, and a string. If we want to create a tuple with only one item, we need to use a comma. We can also access items inside a tuple by indexing. Finally, tuples are immutable. Next, let's see dictionaries. A dictionary is an unordered collection of items. Each item of a dictionary has a key-value pair. The keys within one dictionary are unique. If you store data using a key that is already in use, the old value associated with that key is forgotten. Extracting a value using a non-existent key will cause error. Dictionaries are unordered, changeable, and does not allow duplicates. A pair of braces creates an empty dictionary. There are multiple ways to create a dictionary. We can create a dictionary by braces. We can also create it with dict function. Here we can see x, x2, and x3 has exactly same content. This is key, this is value, and this is a key-value pair, same as these. To access the value in a dictionary, use the key as index. Here we can see the value of key food is spam. If we try to extract a value using a key that does not exist, we will get an error. We're trying to find the value of key A, but key A does not exist in dictionary X. There's no key A. We can avoid such error by accessing the values with get method. With get method, we can specify what value to return if a key is not found. By default, it will return none. Here, x.getA returns none because I didn't specify the return value. And here, I set the return value to I cannot find A. We can also get all the keys and all the values and all the key value pairs. To insert an item to a dictionary, simply assign the value to the key index. To change the value of a key in a dictionary, simply assign the new value to the key index. Finally, let's take a look at sets. A set is an unordered collection with no duplicate elements. Set objects also support mathematical operations like union, intersection, difference, and symmetric difference. We can create a set with curly braces or set function. We can use keyword in to check if an item is in a set. Here, data is not in the set, but text is in the set. To add an item to a set, use add method. To remove an item in a set, use remove method. And since set has no duplicate items, it can be used to remove duplicates. Here I create a set from list 2, then create a list from that set. And all the duplicates are removed. Finally, if we want an immutable set, use frozen set. Here we can see once we change sample set to frozen set, we cannot add another element to it because it's immutable. Now we have learned the data types of Python. I will introduce how to perform different operations on data. First, let's take a look at deep copy and shallow copy. When we want to copy the content in an object, for example, a list or a set, we cannot simply use assignment statement. Because assignment statements in Python do not copy objects. They create bindings between a target and an object. Here I assign A to B. Now, B doesn't receive a copy of A. Instead, we create a binding between B and A. So basically, B is A. So if we modify B, A will also be modified because they represent the same list in memory. They both represent this list. Here we can see A has been modified because of B. To copy the content of A to B, we need to use copy function. Now, instead of assigning A to B, we copy the content of A to B. So if we change the content of B, A will not be changed in most cases. Here we can see A is not changed. And I said in most cases because the content of A can still be changed. Now A is changed. Let me explain why. The last element in A is a list. When we use copy function, Python only does a shallow copy. You can think of it as copying the first layer of A. In A, the last element is stored as a memory address, pointing to the location of the list. With copy function, Python copies the address from A to B, but that address still points to the same list. Here, let me explain it by graph. So, this is list A. We have 1, 2, 3, and the fourth element of list A is a list, which is a memory address pointing to a list. Let's say it's 0x678. And this memory address points to a list, which is 4, 5. Now, when we do shallow copy, we copy everything over here to B. So let's create a new list, B, and we copy everything to B. So B would look like 1, 2, 3, and 0x678. Now, if we modify, let's say we modify this 1 in B to 6, A will not be changed. It's still 1. But the fourth element of B is also a pointer, a memory address pointing to this 4, 5 list. So if we modify this list through B, let's say we change the 5 to 99, when A is trying to access this list, A will find this list is modified. So this way we can modify A through B. This is why if we change the content of the list in B, the list in A will also be changed because they are the same list. If we want A and B to be completely independent from each other, we can use deep copy. With deep copy, we copy everything in A, including the list in A, to B. Next, let's see some data operators. There are assignment operators. Here we can assign 5 to A, and A plus equals 1 means we assign A plus 1 to A. Basically, this means A equals A plus 1. And this means A equals A minus 1. This is A equals A multiplied 2. A equals A divided by 2. And there are comparison operators. This is greater or equal, smaller or equal. This is not equal, and this is equal. So here we can see 1 greater or equal to 2 is false. And this is true. 1 not equal to 2 is true. 1 equals 2 is false. There are also logical operators. For example, true and false. We know true and false should be false. True or false should be true. Not true is false. These are logical operators. And there are membership operators. We have seen it while I'm introducing set data type. And finally, there are identity operators. Identity operator is used to determine whether two objects are same. Here A and B are same because I use assignment operator. And they both point to the same list, this list. But A and C are not same because I use copy. They point to different lists, although the value of A, B, and C are all the same. Okay, this is the end of exercise 2. Thank you for watching.